Hello everybody, we're Team 2420A and we're going to explain the double shot catapult mechanism to you. This is a catapult from a previous robot demonstration. It utilizes the winch system, which uses a ratchet gear to lock the catapult down so it can't unwind and fire accidentally. Here, you can see that the spool rope is attached farther away from the pivot point of the catapult. The way the spool works is interesting. It spins around, winding the rope. This causes the catapult to be pulled down as well. If the spool line that's connected to the catapult is too close to the pivot point, then it'll take a lot of effort to wind the catapult down. This requires more torque, but increases the catapult's wind speed. Connecting the spool to the line farther away from the pivot point of the catapult allows for a faster speed-gear ratio, although sacrifices speed. Now, my teammates Joshua and Preston will explain some other important details about the double shot catapult, as well as some useful tips.
Our winch system only uses one motor, as we've allocated the other motors to different mechanisms. Our winch system uses a 1 to 1.5 torque gear ratio, which allows us to perform with the same efficiency as a two-motor catapult. It also provides enough strength to pull our catapult down quickly after releasing it. I also attached a rebounder, which helps guide the balls that didn't make it into the top goal and into the bottom goal. This can help save some time on scoring the missed goals. We connected a spool line with a metal shaft, as you can see here, so the spool line will not snap. We use standoffs to hold the two balls in the catapult, and the intake wall needs to be tall enough so the second ball can roll over the first ball. We also used another shaft right over here to limit how high the tip of the catapult goes, because without the shaft, the tip of the catapult will go above the 15-inch height limit.
For our robot, we use rubber bands at the back of our robot to power our catapult. The amount of rubber bands may vary. If the rubber bands are connected farther from the pivot point, then less rubber bands are needed to increase the power of the catapult. There are many different types of rubber bands you can use to change the amount of tension that you need. So our robot uses two of these red rubber bands on each side, which are stronger than these orange bands here. The catapult size needs to be as small as possible, because if the catapult is big and heavy, then more rubber bands are needed, and that means that if the tension of the catapult is increased, then the torque of the winch system needs to be increased as well, and that sacrifices speed of pulling down the catapult.
Hope this helps and have fun with your double shot catapult. Bye!